So here is the fourth question. Write down the expression for the following: the Coriolis acceleration and the centripetal acceleration. So the first one is the Coriolis acceleration. That is written as a sub c. And that will be equal to 2 multiplied by omega with the cross product of a v. Now this actually stands for the rotational speed of the Earth, while v, that stands for the linear speed of that molecule. So this is going to be velocity. Now, the centripetal acceleration, I'm just going to write that as ACP. That is centripetal acceleration. That is going to be v squared divided by r. This is actually an acceleration that causes a body, which is actually moving in a circular path, to remain in that path. The acceleration actually pulls the body inwards. So that is what centripetal acceleration is. That is basically the answer to this question. Now the fifth question says, the angular velocity of a moving frame is given by this stuff. If the position vector for the particle is this, then we are required to find out what is the Coriolis acceleration and also to find the centripetal acceleration at t equal to 1. So this is actually going to come off very easy. You just need to pay close attention to what we're going to do over here. Now first off, we got to write out the angular velocity. So that is equal to 2ti. Now bear in mind, I is actually position vector, so I'm just going to write it that way. Okay, and you have minus t squared, and I'm going to represent this also, plus 2t plus 4, and k there. And then we also have the position vector. This position vector could be written as r or uppercase r. So in this case, I'm just going to write it as the uppercase. So that is t squared. Well, so this is t squared plus 1, and that is multiplied by I minus 5t of j, and you have plus 4t raised to the power of 3k. So that is what we have. Now, we know that the Coriolis acceleration, written as a sub c, is equal to 2 multiplied by omega with the cross product of the velocity vector. As you can see, we do not really have the velocity vector right here, but we could actually find that out. So I'm going to clear these out. We know that finding the derivative of the position vector with respect to time is going to give us the velocity vector. So we need to differentiate this stuff. So that will be d dr dt. So what is the derivative of this? If you differentiated t squared with respect to t, that will give you 2t. And if we differentiated 1, that is going to give us a 0. So that is 2ti. And here you have minus 5t. That is going to give us a 5. So that is 5 multiplied by j, or 5j. And on this side, we have 4t raised to the power of 3. So that is going to give us a 12t squared. Now, in this case, we have actually found out what is the vector quantity. So that is v, because we know that v is equal to this stuff. That is equal to dr. I'm going to take this out. We write it dr dt, and that is equal to 2ti. And we have minus 5j. No, to write that. And we have plus 12t squared. So that is what we got. So we need to find out the cross product. How can we find out the cross product of this? Now, first off, we know that this is actually taking place at t equal to 1. So we need to work that. Now, v at t equal to 1 that will be given as a 2 multiplied by 1, and this will be in terms of the first position vector, and here we have a 5. There is no substitution, so that is a j. And here we have a 2t squared, so that should be a 1 squared, and that will be a k. So we have a 2i minus 5j and plus 12k. So that is what we have for the vector quantity. So I'm going to write it here. V is equal to 2i minus 5j plus 12k. Now we also know what the acceleration, no, in this case that is angular velocity. That is equal to 2t minus t squared. So this is an I, and here we have a j. And this is going to be 2t plus 4. We need to find what that is. So at t equal to 1, omega, that is going to be equal to ti. Well, that should be 2i minus j. And we're going to have a 2 multiplied by 1. That is a 2 plus 4. That will be 6. So this is plus 6k. So omega is equal to 2i minus j plus 6k. Next up, we need to plug this into the formula. Now we know that stuff should be the angular velocity multiplied by the velocity vector. Now this is a cross product, so we need to work it. So this is I, this is j, and this is the k. So this will be the plus, this is a negative, and this is a plus. So for the first one, that is w, that is a 2, and we have a negative 1, and we have a 6. And for the v, we have a 2, that is a negative 5, and we have a 12. So we need to work these. So I'm going to wipe these out. Now first off, you need to take this and clear out all the entries within the same row with it, as well as the ones within the same column with it. So that leaves us with this stuff. Now you need to find the determinant of that. Negative 1 multiplied by 12, that is going to give us a negative 12. So that will be I multiplied by negative 12. And you need to subtract that from this multiplied by this. So we have negative 5 multiplied by 6 to be a negative 30. So that will be minus 30. That gives us a plus 30. Next up, we take a negative j. So that is going to be a minus j. And we have this. So these are going to be cancelled out, and these ones also. And that leaves us with 2, 2, and 6 half. So that is 2 multiplied by 12. That will give us a 24. And that is minus 2 multiplied by 12. Well, 2 multiplied by 6. That is a 12. Here we have a plus. So that is plus k. And that is going to have these cancelled as well as these. So we should have a 2 multiplied by negative 5, which gives us a negative 10. And we're going to have a negative 1 multiplied by 2. That is a negative 2. That should be a minus negative 2, which changes to a plus 2. So the new vector, which is the vector for the cross product, that is going to be negative 12 plus 30. That gives us 18. So that will be 18i. And here we have 12, 24 minus 12. That gives us a 12. So that is minus 12j. And here we're going to have a negative 10 plus 2. That is an 8, negative 8. So that is negative 8k. So that is what we're going to have for the cross product. So we know that omega multiplied, well, with the cross product rather, of a v is equal to this stuff. And the final stuff is we need to take this and multiply it with a 2. So 2 multiplied by the cross product, that is going to be 36i, and here we're going to have a 24j, and that will be minus 16k. So this is the Coriolis acceleration. That is the first answer to this question. Now next up, we need to find out what is the centripetal acceleration. Now, in order to solve this, we need to find out what will be the value of the velocity at t equal to 1 and the value of the position vector at t equal to 1. So we know that the centripetal acceleration is written as a sub cp, and that is equal to v squared divided by r. Now, we know that v, that is the vector quantity or the velocity vector. We know that was the change in the position vector divided by dt. That is with respect to that. And what did we find? We actually found 2ti minus 5j, and we have plus 12t squared. Okay, so that is what we had. Now we need to take this and find the magnitude of this stuff. But you know that there is a square already. Now the magnitude of this should be the coefficients of this stuff all squared, and the square root of the whole sum taken. Now we know that that square root is going to be cancelled as a result of the square here. So instead of doing that, we're going to move a little bit more gradually. So first off, let us take this at t equal to 1. So taking that, that is going to give 2i minus 5j, and here we're going to have a plus 12k. Okay, so let us take the position vector. The position vector at t equal to 1, we're going to have it as a 1 plus 1, so that will be 2i, and this is going to be minus 5j, so this is a minus 5j, and that will be plus 4k. So first off, we need to find the magnitudes of these stuff. So I might wipe these out also. So let us find the magnitude of v. Now we know the magnitude of v, that should be something like this. That will be 2 squared plus a negative 5 squared. And that will be plus 12 all squared. Now we know this should be squared. So if you have this should be 2 squared plus a 5 squared. And this will be 12 squared without the square root sign, because you're going to have this square cancel out that. So this is going to be 4 plus 25 plus 144. So let us find out. So that gives us 173. Now we're going to write this as a meter per second as a unit for a vector. So we have v, the position vector, that is equal to this stuff. Next up, we need to find the magnitude of the position vector. This is the velocity vector. So I might have made a mistake there. This is the velocity vector. Now we need to find the magnitude for the position vector. So that is going to be absolute r. And that will be this. So you have a 2 squared minus or a plus minus 5 squared. And this is a plus 4 squared. So we know this is going to give us a 4. This is a 4. And this is going to give us a 25. And for the last one, we're going to have a 16. So let's see what that gives. So that gives us a 6.71 approximately. and this is in meters. So we have everything that we need to solve for the centripetal acceleration. So we're going to jump right in and find out what that's going to give. So we know the centripetal acceleration is this, and so that is going to be v squared. So we know v squared, so I should have written this, so that is what you have, because v alone is actually what we had there, but we had v squared, so that is actually going to change. So v squared is equal to 173 meter per second, and that is divided by 6.7 meters. So let's see. Well, this should be also in square, so I'm going to change this. This should be meter squared per second squared. Now this is going to cancel one of it away from here, and we're going to have 173 divided by 6.7. So that is 25.821. So ACP is equal to 25.821. And this will be meter per second squared. So this is the answer to the centripetal acceleration. That is basically how to solve this question.